Alright, this is a quick video just to go back over binary subtraction, which I probably could have done a clearer job of last time that I went to explain it. So we have here just an Excel spreadsheet. It just keeps everything handy and it's quick and easy to look at. So we have number 1, we're going to subtract number 2 from it. So we have our values up here, so we'll be able to check our work later. So we're going to start with the 1 bit. So we're subtracting 0 from 1. That's pretty straightforward. It's just 1 there. So now when we come over to the 2 bit, we're going to see that we're trying to subtract 1 from 0. We can't really do that. So we're going to do just like we do in decimal subtraction. So we're going to borrow from the 4. So we're going to treat it as though we don't have any 4 bits, right? We're going to use our carry over here, and we're going to call this 0 4 bits. But because 2 plus 2 is 4, then we're going to treat it as though we have 2 bits, right? So now we can subtract 1 from 2, and that gives us 1. I know that seems weird, but just bear with me. So now we come over to the 4's place, and so now we're going to subtract from the carry, because we've effectively changed the value that was in the 4 bit. So we're subtracting 1 from 0, so we're going to have to borrow from 8, which means we do exactly the same thing we did before. We're going to treat our 1 as if it is 0, and then we're going to treat it like we have, because 8 times is equal to 4 plus 4, we're going to treat it like we have 2 4 bits, right? So now we're going to subtract 1 from 2, and we'll just have an answer of 1. Now we come over to 8, and we kind of have the same problem again. We have 1 coming out of 0. However, we don't have any 16-bit to borrow from, so we're going to have to go over to 32 and borrow from there. So first thing, we'll do the same thing. We'll treat our 1 as though it is 0. So when we come over to the 16, for just a moment, we're going to pretend as though we have two 16 bits, because 16 plus 16 equals 32. However, we don't need to subtract anything from 16. We need to subtract from 8. So we're going to do this again. We're going to reduce this number by 1. Right? 16 goes to 1. And now we treat it as though we have two 8 bits, right? Because 8 plus 8 plus 16 equals 32. So now we're able to subtract 1 from 2, and we get 1. So when we come over to the 16-bit, we're subtracting 0 from 1, which is just 1. And then in the 32-bit, we're subtracting 0 from 0, which is just 0. In the 64-bit, we have 1 from 1, which is just 0. And then in the 128, 0 from 1, which leaves us with 1. So as weird as that may seem, we essentially do the same thing in decimal. It just doesn't look quite as strange. But when we look at the decimal values, we can see that everything adds up. So you can work the additional problems that are given in the sheet, but this is essentially what you're going to be doing on quizzes and tests and such the like. Though honestly, I think your homework is less complex than this.